Hello everyone, welcome back to Infinity Physics. In this lecture, we will discuss about refraction of light. So, in the last lectures, we had a discussion about reflection of light. So, what do you mean by reflection of light? In that case, suppose there is a mirror or any polished surface which is opaque. Now, when light incident on this opaque or a polished surface, it reflects back, that is, it bounces back. This is called the reflection of light. But instead, suppose we are having here a transparent medium, that is, suppose here we have glass or water, anything, and here we have air. So here both medium are transparent medium. So when light is traveling from air to glass, right, it will reflect, somewhat it will reflect, but the maximum light will be refract. That is, it will pass from one transparent medium to another transparent medium. In the reflection, what was happening? The light was bouncing, but in this case the light will enter the medium. From one transparent medium, the light is traveling into the another transparent medium. So what will happen here? The light will bend. Actually it is going straight, see, but when it's entered from one transparent medium to another transparent medium, it will bend, right? So let us see how it's bend and what is the cause of refraction of light. So refraction is a bending of light when it enters obliquely from one transparent medium to another transparent medium. So here what is obliquely? Obliquely means slantly, at some angle, right? So here you can see this pencil is entering the medium slantly, that is obliquely. And what is the cause of refraction? The cause of refraction is the change in the speed of light. That is, suppose you are traveling, you are walking, you are running on a concrete, okay, you are running very in a very high speed, and suppose there is a desert sand ahead, then what will happen? Your speed will decrease when you enter the desert sand. Similarly, when you enter the water, from a concrete to water or from a desert to water, then what will happen? Your speed again decreases. So when you change the medium, the speed decreases, right, or increases depending upon. Now suppose after entering the mud or water, again you are moving on a concrete, then what will happen? Your speed again increases. So here what is happening? In the vacuum or in the air, the speed of light is approximately 3 into 10 to the power 8 meter per second, that is 3 lakh kilometer per second. Now when from air, suppose here we have a separation between the two medium, here we have air and here we have water. So what will happen here? When light, which is traveling with a speed of 3 lakh kilometer per second in air, now it is entering into the water, that is from one transparent medium to another transparent medium, then what will happen? Its speed will decrease, and due to the decrease in the speed, the light will bend. And this bending of light and this change in the velocity of light when it is passing from one transparent medium to another transparent medium is known as refraction of light. So here are the some examples which you see in our day-to-day life. So here the pencil appear bent. You can do it by yourself also at your home. So if you place the pencil like obliquely here in a glass filled with water, you will find that the pencil bent. It appears to be broken. But here actually when you remove the pencil from the glass, you will find that the pencil is not broken. Similarly here you can also observe, if you are a swimmer or if you are regularly visiting swimming pool, you will observe that when there is a water in the swimming pool, the lower part, that is the bottom of the swimming pool, appears raised, appears higher, but when there is no water, you will see its real depth. So this is all due to the refraction of light. Here you can see that the actual coin is lying here, but due to the bending of the light ray, you will find that the coin is appear to be raised. So similar things happen with the swimming pool. Here lemons placed in a glass tumbler appear bigger. So here you can see that the lemons are placed in a glass and they appears to be bigger. Similarly, you can place a glass slab or a scale on the on your book, and you can observe that the writings appear to be raised, and this is all due to the refraction of light. Like there was a laws of reflection, there were laws of reflection. Similarly, we also have laws of refraction. Okay, in case of a reflection, we have two laws. Here also we have two laws that to be followed in any kind of refraction. So what is the first law? The incident ray, refracted ray and the normal at the point of incidence all lie in a same plane. Now you all know about the plane, right? What is a plane? So I will not go into the depth. So here this is our incident ray, this is our refracted ray and the normal. Where to draw the normal? The normal should be drawn at the point of incidence. So here we have the point of incidence where we have drawn the normal line. So this is our normal line at the point of incidence, and the incident ray, refracted ray and normal all lie in a same plane. Now the second law states that the angle of incidence. Now what is the angle of incidence? The angle with the normal and the incident ray is known as angle of incidence, and the angle with the normal and the refracted ray is known as angle of refraction. So the second law states that when a ray of light undergoes refraction, then the ratio of sine of angle of incidence to the sine of angle of refraction is constant. That is, at whatever angle, see here, this is how this is, we have here angle of incidence and this is angle of refraction. Now you have to apply a trigonometric function sine, which is ratio of the opposite side upon hypotenuse of a triangle, that you will learn in the trigonometric section. So here the ratio of the, here we have angle theta 1, that is angle of incidence, or we can say angle of incidence is I and angle of refraction is R. Then you have to apply the sine function to both the case. So here sine I by sine R. So for a particular medium, that is for a given pair of medium, this ratio will always remain constant. I know you have not got this, but let me try to explain it. Suppose here we have a one pair of medium, that is here we have air, and let us assume that here we have glass. Okay, then what we have enter a ray of light. Here you can see this black line is normal. So here the ray of light is entering here like this, it is making some angle, right, and it undergoes refraction. Now let us assume that in the first case the angle is I1, angle of incidence is I1 and angle of refraction is R1. Then what we will do, we will apply a sine function here, sine I, and here sine R. We have to apply sine function, then we have to take the ratio. Now suppose at whatever, suppose we get some angle and then we have taken a ratio sine I by sine R, and we have obtained, by putting the value of angle of incidence and angle of refraction, we have obtained a value, and that value we have obtained is 1.5, right. Now we are changing the angle, we are keeping the same pair of media, that is air and glass. We are not changing the pair of media. So in the similar medium we are entering the another ray with the different angle, right, same pair of media but the angle is different. So here again this our angle I2 and angle of refraction is R2. Now again we apply the sine function sine I and sine R, and then we will take the ratio. So it is sine I by sine R, and we get again the same ratio 1.5. So in all these cases we will get the same ratio, right, and that is called, that is the second law of refraction, which is known as Snell's law. That is, when a ray of light undergoes refraction, then the ratio of sine of angle of incidence, that is sine I by sine R, is always constant for a given pair of media and a light. Right. Now suppose the medium is changing. Suppose the upper side we have air and in the lower side, that is the bottom, we have water. Then the ratio will change and the ratio will become 1 and the ratio will become 1.33. If there is a water, then the ratio will become 1.33 sine I by sine R. Right. And similarly, suppose if there is a medium, kerosene, then the ratio will be 1.4. Right. So suppose if you are changing the medium, then the ratio will change. But for a given pair of media, at whatever angle you are going to incident the light, and if you take the ratio of the angle of sine of angle, that is by applying the sine function, if you take the ratio of sine of angle of incidence to the sine of angle of refraction, then you will always get a constant value, and that constant value is known as refractive index. That constant value is known as refractive index. Now what is refractive index? The understanding of the refractive index is very important, and it is very interesting, and that we will see in the next lecture. So